Hey guys, welcome back. I wanted to talk a little about linear functions and transformations. So imagine that you have this variable called x and it only has these three numbers and there's no other numbers. So this is not a sample, but it's the population. Now, what would the average of 1, 2, and 3 be? Well, 1 plus 2 plus 3 divided by 3 will give us an average of 2. I went ahead and I did the standard deviation for you guys, and the standard deviation of 1, 2, and 3 is 0.816. So let's take a quick look at the standard deviation. We know the standard deviation is the amount that each point differs from the average. So 1 differs from 2 by a -1, and 2 differs from 2 by 0, and 3 differs from 2 by +1. Okay, and there's some calculations to come up with this standard deviation, but right now I just care about the distance of each point. What if I went and I just added 5 to every single data point? Well, 1 becomes 6, 2 becomes 7, and 3 becomes 8. That average is now 7. And that's actually very interesting because what happened was when you added 5 to all of these numbers, the average increased by exactly 5. Now, the distance for the standard deviation is actually going to stay the same. It's going to stay as 0.816. You can confirm this in a calculator, but I want to show you why. The distance from the average would be the standard deviation. So the distance between 6 and 7 is a -1 as well. From 7 to 7 is 0, and from 8 to 7 is +1. And what you notice is, if this standard deviation gave us to 0.816, so this should give us the same thing. So actually, only the average changes by the constant, but the standard deviation never changes when you're adding a number. What happens when we multiply a number? Well, if I multiply 5 times each one of these elements, I would get 5, 10, 15. Well, my average is 10, so you notice that it went from 2 to 10, so you actually increase by a product of 5. And let's see what happens with our standard deviation. The distance from 5 to 10 is -5, and from 10 to 10 is 0, and from 15 to 10 is +5. Well, in our original problem, it was -1, 0, and +1. If I factor out a 5, then I would get these numbers. And what I'm trying to say is basically that the standard deviation is whatever the original standard deviation is, but times 5. So when we add a constant, only the average, or I should write down mu, changes by that. The standard deviation does not change at all. But when you multiply every data point by a constant, both your average and your standard deviation changes. So let's take a quick look at these two great examples I made up. First, I want us to talk about a linear function. It's basically exactly what I did on the previous slide, but I just put it into some sort of equation. So I said, assume that x is a random variable with average to be 10 and a standard deviation to be 6. So I wrote those right there. Let me once again take this off, and I'll just put a mu there. So I wanted us to transform these data and figure out what the new average is. Well, this here, guys, is a product, and this here is a constant that you're going to add or subtract. So remember that averages are affected by both a product and an addition or subtraction of a constant. So the mu is actually going to be, I'm going to put mu of L, is going to be 5 times 10 minus 4. And so that's going to be 50 minus 4, which is 46. the standard deviation is not affected by this guy right here. He's not affected by adding or subtracting a number. So, with that being said, I'm going to take 5 and times it by this guy here, and that's going to be 30. Now, I really should have said we should talk about the variance first, because that's actually really important. But because this is only one variable, it's going to reduce to the same value. So let's look at this guy right here and try another example. What would happen if we put the 10 as the average through this machine here? Well, mu is going to be 0.5 times 10 plus 2. So an average is affected by both the product and addition of a number. So that's going to be 5 plus 2, which is 7. But the standard deviation is not. It's only affected by that 0.5. So the 0.5 times the 6. So that's just going to be 3. So some of you might say, well, where would you use this? So let me show you in this example where we would use this. On a physics test, the class average was a 34. Yikes. I'm going to say that's mu because it's the entire class. And the standard deviation is actually 9. The teacher decides to curve the exam by multiplying everyone's grade by 2 and adding 12 to each grade. What is the linear function that can be used to transform the data? Well, if you're just going to multiply everybody's grade by 2 and then add 12, this will be our function. And now it says, what will the new average be? Well, an average is affected by both this and this. So it's 2 times 34 plus 12. And a standard deviation is not affected by the 12. So we have 2 times 9, which is 18. Once again, I probably should say 2 squared times 9 squared is equal to the variance squared, and then take this. And that's actually important because when we end up combining more than one variable, we can't just add standard deviations. We learned in the last video that you would have to square them, add them, and square root. Well, this is linear functions and transformations. I hope this video was helpful. Stay tuned for the next one where we use 2 variables. Thank you.